Greetings and assalamu alaikum everyone. From my side, good evening to all. Today I would like to talk about CNN part 2 where I will my goal is to show how to CNN use for tabular data as well as image data, and we know that CNN is very popular for image data. So let's start. Before I start code, I would like to recap the something that I told in the last week, that how the computer vision is born and how the CB works, and there we also saw the architecture of CNN. And just for a quick recap, whenever we as a human we saw a image, we can less than 3 seconds we can capture all about these images, like where we can see that the group of football teams and people celebrate their winning moment, and here in the back stage we show that there letter some combination of letter winners. But how the actually computer read this image? Well, they, in terms of computer, they show an image if it is RGB method. They show in the three metrics, and when it is a grayscale image, it like this 2D. And we also saw the definition, and there are some remarkable type of computer vision like object classification, object detection, face recognition, and face detection. And we saw an example of how CB work for face detection. And we will talk the theory part of CNN, why CNN is arrived. Well, just a short intro here. Uh, as like earlier I said that whenever we saw an image, it takes less than 3 seconds for a human brain to capture all about the eyesight. Like if you look this image here, you can see that there is a dog, and there is a dog eats something like apple, and its background is like green and some combination of other color. So when we as a human see the picture, usually we parallelly see about the object, like not only focus the particular object, as well as we can our eyesight goes to the out of object too. So from here the CNN actually the model drive like this, at a time multiple feature it can extract. And this is the typically of and okay, sorry for the interruption. So like this is an typical one of the, you can say like this, the advanced version of CNN BGG69 architecture. So as we talk about CNN, so forget this three letter and the number, just CNN architecture. So this is an RGB picture. So whenever we pass the picture, we can see that this is the shape of this picture. And don't worry about this 64. uh, Excuse me. And we saw that the size reduction when it passed to layer, and finally before in the fully connected layer. So the size 7 into 7, so 2 to 4 to 7. This is the actually main aim for the CNN, that extract the features, main features, and reduce the extra size of an images. And and yeah, this is and another example that we also described. So here I um, just uh, just previous slide we saw that here we put image. Similarly, just here we see that the sum value between 0 to 1, and this is our, you can say that the image matrix or a 2D matrix. Then it pass the convolution, then pooling, and finally uh, flatting array before NN call. And I also mentioned that how filter actually work. Sorry for that, the picture is not as much as clear that I accepted when I add, but you can visualize that the filter, how it moves and how to uh, this is the actual input image and this is the filter input. So how it, each kernel uh, or we say the filter moving one by one column, and then it takes this, and this is how works in the RGB. Like in the RGB method it has three array, we know that. So like how the filter works here, you can visualize that. And finally this three aggregated output is this. And here is the another clear view filters. I took this gif from the Microsoft computer vision, uh, Microsoft Learn site. So here you can see that how filter the move in a image, and here you put some value. And this is there are different type of filters for edge detection, identity, and Gaussian blur. That's all about that we talked in the last week. Now it's time to show today's start today's lecture from here. Okay, so how actually image size reduce? Okay, this is our goal. So I just consider one convolution for simple understanding. And so okay, and this is our pattern. Okay, so this is our images. I hope you can visualize the images. Let's assume it size is like 60 to 60, and consider that this is an RGB image. So here I some put some color, as you can see that this is RGB. Okay, well, so this is our convolution layer, and convolution layer it inside has a activation. So just for simplicity, so one convolution, and we know that the max pooling following the convolution layer. So here we add pooling layer, and this is our FC. So before FC, we want to show that how the image size reduce. Okay, so uh, there is an formula which is like this. I will describe about it. So what does n represent here? N means the input size of the images, P for padding, and F filter size, S for stride. Okay, so don't be panic. I just visualize, then I will describe that it easy for you to understand. Like our input shape is 4 into 4. So here 1 2 3 4, you can easily visualize that there is 4 row, 4 row and 4 column. So if I set the kernel size, initially the kernel size is 1. So if I say kernel size generally 3, so you can see that the 3 into 3 matrix overlap the actual input shape, and for understanding I just move it 6. And the padding, well, so what is padding? Uh, Sometimes in our, this is our input, when the kernels move, like whenever is the last column, then it move to outside of our range images, then we can lose some information or there is. So protect this information, we add padding. Like if we add a padding one, that there is basically it's called zero padding, which means that the extra input and column around the actual images all are set by zero. But here you didn't notice it, just you can also, you can show that there is a gray color and the input shape is white color. So and the stride, what does the stride represent or means here? Well, so we see that this is one by one room slightly move, and then whenever we set the stride to it, if you look this, it move uh, two column at a time whenever it's moving. So for understanding I said three. So like how quickly it passed, just notice the animation. So well, if I raise the size, then we can also clearly, so this is the visualize actually how padding and stride work here. So for our calculation simplicity, we set padding 0 and kernel size, let's say 3, and as for stride, generally by default 1. So okay, we I can run this 2 times similarly for as 60 into 60, same output we go for the time bounding. So I just write 1. So from here we know that our input say is 16 to 60. So here we just pick the 60, and as the padding is 0, we know that just put the value, and kernel size 3 plus 1, basically this is plus 1 here. So and stride 1. So if we divided this like just basic subtraction and addition, we got 0 here. So 60 minus 3, we know that 57 plus 1 and 1. So whenever we divide something 1 divided by something 1 with others, there is, we know that the nothing is changed. So my bad, here is 58. So you can say that after one convolution we got 58 into 58. uh, Similarly, if I copy this and paste here, similarly I got again 58 for these two. And the things you must be focused that here the input shape we got 3. So like I just filter 32 filters, so here I got 32 filters. So uh, you maybe uh, confused that why the number changed 3 to 32, as this is we know 3 for RGB means. So what does the 32 means? Well, in the convolution, what it actually do, basically it reduce the size of uh, images. Okay, so and it extract the features. Like if I goes to the previous slide, so uh, in this RGB picture, we know that we see here there is an images to 3 channel are uh, green blue. So 32 means like consider this is a feature from this, and this feature from here, this feature from here. So for simply understand that 32 stack of images, which means that we entirely divided our image 32. So we don't know actually which feature is important or which feature can uniquely identify from others. So that's the thing handled by computer. But just for imagine, like this is one feature, this is second, third, fourth, fifth. So like this I divided my entire image into 32 filters. So this is the stack of 32. If I draw here for like this, okay, I should rather one use one this one. So like this is my images. So I got 32 different metrics. So 32 different metrics draw is impossible. So like this, so these features here, these features represent this metric, this feature represent. So we know that it image has a number collection of pixel, and features means the particular region from an images, like this is. So this region is an feature for these images. So like this 32, simple to understand, don't bother any. So what here in the pooling layer, what does it actually do? We know that if we apply the same formula in the pooling side, as there is no filter used, just we simply and pooling layer the start is 2. So like this I wrote again the formula here, but it must be increase the canvas. Okay, I use the same formula again for the pooling size. So mm, what's happened, man? Weird things happening with me. I don't know how to. Okay, so I hope this will help much. Okay, so here is the our formula. Same formula we can apply here. Currently our images size is 58 into 58. So if I like this, and again our image uh, padding is 0, so here we get totally 0. And we know that our filter size previously 3, but here the padding size by default 2. We can also increase it. And okay, so like this divided, so we got something like 27 and plus 1, so 28. So for one expo we got this size is 28, but here the filter size goes to rise, like this going to be 64. So here we can write 64 here. So you can see that initially our image size is 60, but after one mix pool we got 28 into 28 size. So whenever we add more convolution layer, the size going to smaller. And finally in the FC, what we add, like consider this is our image shape, and we reach here, this is our filter, so final filter like 128. So if we calculate this, we will find a number. So this is our fc value, and this we can pass the neural network. Okay, and then actually it works. So in the last day, I mentioned that, like I again told it, uh, in ANN, I mean artificial neural network, what actually happened like this. So this is an image. So if it is 200 into 200, like this shape, so it like 4. So the fc size is like this. So how many, it calculate all weights, but in the CNN it is partially fully connected, which means that, like this is our uh, hidden layer 1, like one node, and where is I use different color, and where, so it actually connected like these three, and this connected like, so partial connection is like something like this, and where you can see that the two node reduce. So that's the way we reduce the feature size, image size, and finally we got a less computation than compared to artificial neural network. We just consider the main feature rather than the full images. Okay, so now moving to our second part, that is coding part here. Firstly, we we saw and hard disease data. How do we apply the CNN here? Uh, well, once again, I want to back again the drawing page. So 1D convolution, what does it mean? Like this, my feature is 1D. Okay, that's why it's considered we 1D. So in terms of when we use convert 2D, so when we got the metric image size is a matrix 2D, so that's why we use 2D convolution. Okay, so we know that this data is tabular data, and if here we justly basic input the library pandas for data, uh, dataset manipulation or data read, I use panda here, and p use, we know that for basic calculation, and uh, for CNN we must need the sequential model. So why need sequential is important. Well, so if I the graphical view to the share to the architecture, you saw here that this is the one layer, second, third, this is one after one sequence. That's why we need the sequential, and here from the Keras layer we input convolution 1D, max pooling, flatten, dense, and dropout. I also several times told you that what does the dance represent here, and we know that how to read a data set from the local, I mean in the collab. So if we run this, we show the first 5 value. Here we can see that it has totally 14 column, among them 13 are features, and final one is output for me. And you saw that there are uh, some graphical views with the features. So here if I print the correlation, so from the correlation with features, and with output, so we show that there is uh, some value. You ignore the negative sign, but if we saw that there is no zero, so that means that we can consider all the features are required or important for our output. So if I got like this CP, so if I found here is 0, so that means that it is uh, less impact compared to the age, so we can ignore it. And so I check my data set that it has any null value or not. So uh, I got there is no null value. So this all about the pre-processing a data part. So before we start our model directly, we must be pre-process our data and pre-process the code part for running any machine learning or deep learning model. So we can use normalization here, and we know that the normalization range is 0 to uh, uh, okay, somewhere we can see that -3 to 3 or -1 -1 to 1, the normalization range value. And after normalization we can see that the value is here. So by default it use 3 to -3 to +3. And finally we here in our the convolution layer. So first of all I add the sequential, and in the convolution 1D is my dataset is tabular, and I use filter 32 and kernel size 3 activation as a value, and I pass the input shape. So here you can see that after the filter 32 and polling size 2, we know that we use 64, then second flatten add, and here. So we can add h many add one to convolution, but like this we can add another one in the below, and as much as add flatten. So also we can add here like this 64 do not dense too. So like I add another dense layer which has 10 and as the activation value, and dropout means that we ignore some data. So we use here optimizer. Optimizer target is to optimize our model, and I use here loss as a binary cross entropy, which is means that our data set has two value in output. One is 1 and 0, that's why we use binary cross entropy here. And as a matrix we use whenever we look for the uh, we look for accuracy to optimize our during the optimization. And we split the data set here, and you see that there is a number of in the machine learning we just called fit model fit and pass the x set and y test data set. But in the deep learning we have also defined that the epochs and batch size and the validation. So validation also we know for that or to make our model better we use some data from training set that uh, mis- that model can run well, and try to less reduce. So what does the epoch and batch size here means? Okay, so like this here you can see that the epoch is 100, and okay, just ignore it. Okay, and batch size is like 32. So like this our data set has 1000 training data set images. So each batch size means that each iteration it goes 32. So if we divide like this 32, so wait, calculate this. Okay, so Okay, we just round the value, we got 31. So one epoch, the entire data set run 31 iteration. So total 100 epochs, which means that each time 31. So 100 time, you know that this is the entire dataset iteration. Uh, and okay, 5 minute break. Okay, we are back again. So last time I told you that there how batch size and the relation of epoch. So simply epoch means that whenever we run a for loop, we define the number of n values. So how many time run a loop actually. So this is the number of epoch. And uh, is it fixed or like this two value is fixed? No, there is called, or we can say that hyper twin. So the number of epochs and base size we can increase or reduce depend on our the data set, and there is no fixed value. And we saw that I didn't add here any checkpoint, or so that's why it ran 100 value. So we saw that there are some um, validation accuracy uh, up and down fluctuate their value, so like this. And and at the end we calculate the loss, test loss focus. The more we loss the focus, so the best our model. So here we see that the value is very high. So how do we reduce it? We can reduce the test loss using different we can change here like this. If we add here sigmoid and activation, we can see the output will be changed. And we can also increase the value, like I add here, just I run, and just 200, as this is tabular data, I didn't take it much as time. And I change the optimizer as like SGD, so stochastic gradient descent. And uh, okay, nothing changed, just restart and run all. It not take much time, like within I blink it will be finished. uh, so okay, yeah, start working. So it didn't take already, it takes 24:32. Okay, so later on this I will also receive the CIFAR-10 and fashion data. So one is 3 channel and another one is 1 channel. So you will see that this is complete. So can you imagine that in the earlier, I mean, a few seconds ago, before run this, you if you notice that there was test loss zero point 0.7. Now approximately 50% reduce. So this is the way we can improve or better a model. So I just disconnected and delete the runtime. Okay. So now we know that when the CNN had, we think that like the image, where is the actual image got? Okay. So here I am using from Keras dataset, see the CIFAR-10. So there is many toy data available. So you can use anything that one. So its name already, the CIFAR-10 small images classification data. So this is the explanation about the data set, like the number of level and the description. And it has 50,000 images, and which size 32, very small size, 32 into 32. And 10,000 images for test level, so approximately 60,000. So okay, let's see. So this is the desired or required library that we need, and this is the way how we can download a toy data or predefined data as the size is too reduce. In real life, the images size may be above this 2 to 4. We There is also in image learning, the challenging part is load the local data and normalize this. And we also here use the conversion and this, and here we use a default method from the Keras to convert, as we know that it has 10 categorical output. So we just show some training data, like how is this. So we can show that we can see that the images are blurred, like this is horse, this might be sheep, car, and animal. So over the time randomly pick 10 images. So this is our for actually a CNN model looks like, how we must be defined. So we know that how to define class, and inside the class how to write method in Python. So this is our in constructor, default constructor, what we have to need or require initially and assign this. So in the build model, actually we working here. So we use padding same input shape, and if you notice that here we use convolution 2D, and we pass filter 3 and 3 into 3 as the image filter size, 32 filter size, and this 3 for mention that the images in RGB mode. And uh,